All right, so interpreting graphs. So questions pertain to this histogram. All right, so let's address a histogram first. So it says how many students are in the fencing club. So when you have a histogram, obviously the bars must touch, and you've got the frequency along the y-axis. So then just add up those totals, and you should end up with, anybody got it? Who's got it? What do you got? 18. Okay. Now it says how many students' heights are greater than or equal to 66 inches? Greater than or equal to 66 inches. So let's look at this, the way this is labeled. So 54 would be for that first bar, then 56. Nobody falls in the 58 range, 60, 62, 64. Here we go. 66 or greater. So we want this bar, this bar, and this bar, and we end up with 7 people are greater than or equal to 66. Now this next one says, what percentage of the students have a height greater than or equal to 60 inches, but less than 66 inches to the nearest 10%. Okay. So we've got to come up with that part over the total. So we know it's going to be something over 18, and then we're going to have to divide to get that to the nearest 10. So students have a height greater than or equal to 60. I'm just going to erase what I put there. Greater than or equal to 60, but less than 66. So we don't want to include the 66 bar. So we've got 2, 2, and 4. That gives us 8 out of 18. What is that to the nearest tenth of or percent? Who's got it? Who's got it? Nearest percent? 44.4%. Okay. In which interval will you find the median student height? Okay. The median. If we've got 18 students there, the middle of 18 is what? Right around 9. Okay. So if we've got 1, 2, that's 3, 4, 5, 6, 7. Okay, right in here, that median is going to fall, and that's going to be that 64 to 66 interval. So we could say less than or equal to H, which is less than 66. Okay, because they did ask for an interval. Most times when you see a histogram, they won't have just these specific numbers here. They will have intervals. Okay, like I said, you're in interval. They may have something like that to represent each bar. Okay. Very rarely do you see just with numbers down at the bottom. Okay. Next one. So we got a box of Lister. Represents the points scored in each game for the 2013 fall football season for 2 area high schools. In general, which team scored more points per game? More points per game. We're looking for the max there, which is going to be what, Paige? Team B. Yep. Its max is 45 and its max is 40. Which team's data shows more variability in the points scored? You want to pick the one with the wider box, okay? Because the box is going to test the variability, okay? So the wider box. So that's going to be team what? Anybody? Team A. And then it says, what is the difference between the median points scored by these two teams? So the median is the line inside the box. And they want to know the difference, so we know we're going to have to subtract those two. So we've got 30 and 21, so our median is 9, or the difference is 9. Okay? Let's see. All right, let's talk about a little dot plot here. Okay, and then in the same warning, 15. Okay, a lot of times in the directions they'll tell you how many data points you have. Spend money on $5 lottery tickets. Don't go too far. What is the median of the dollars spent? So in this case, when you've got a dot plot, do it the old-fashioned way. Okay, where you cross off a high and a low. So just kind of go through and cross off a high and, did I just confuse myself? 1, 2, 3, 4, 5, 6. 3, 4, 5, 6, 7. There we go. 7, 7. We are at 40. Okay. So that's our median. The mean or the average dollars spent. I'm not going to take time to do that, but to find the mean, we're going to add and then divide by 15. So get that sum and divide by 15, and we're going to get 31. First quartile. Okay, first quartile. Now, obviously, we could, okay, go through and enter this data into our lists and spreadsheets, okay, and then go menu, statistics, back calculations, one variable statistic, and then it's going to spit out all that information. What other questions are they asking? Oh, we got to do standard deviation anyways. So, yeah, so let's go to our calculator and enter all of this data. So, nope, I lied. I went to the wrong place. List and spreadsheets. So I'm going to pause while we enter this. All right, so we're going to go to menu, statistics, stat calculations, one variable statistic. We got one list, and we called it X. And so now, as we scroll through, there's our mean. Okay, X bar is your mean. And then keep scrolling through. Let's just kind of review what all of these titles mean. So SX that I'm highlighted on right now is the sample standard deviation. Then sigma X, which is next, is the population standard deviation. Scrolling through, N just means the number of data points that we have. We have 15 data points. Okay. There's our min. There's Q1, okay, quartile 1, which I think we just needed to answer. There's our median, 40. Q3, or the upper quartile, which is 45. There's our max. Okay, so all the other stuff that's on there that we didn't talk about, we don't need to know about. So, where are we? So, first quartile. Okay, so Q1, sorry, I scrolled past that, it's 15. Okay. Interquartile range. So, that's 15. Interquartile range means Q3 minus Q1, the difference of the box. Okay, that's the IQR. So Q3 was what? Who's got it? Q3 was 45, and then Q1 was 15. So we end up with an interquartile range of 30. And then the population standard deviation to the nearest 100th. Population means you've got to look at your sigma. So nearest, there we go. Okay, nearest 100th, so it's going to be 14.05. Okay. We good with that? Okay. And yep, I think we're good. So let's see, this is more, okay, we've talked about a box plot. I think we've hit on the high points. All right, next page. So that's interpreting graphs. I think we're good with that. Next page is standard deviation, right? Yes? Okay. I have mine out of order, that's why I questioned you what was next in our... That page next? Cool. Alright, so what do we want to practice? Let me look. Let's do... Let's see which one we want. Alright, let's do number 2. Okay? Let's do number 2. Just another little practice. Okay? With the calculator. So go ahead and enter your data for number 2 into the calculator. Find the mean, sample standard deviation, population standard deviation. So mean, x bar, sample standard deviation, sx, population standard deviation, sigma x. Okay, so you should have 10 data points in your lists and spreadsheets. Menu, statistics, stat calculations. Again, we only have one variable, one list. Oops. Oh, I think it already gave me my information. I think I hopped over something, but I think we're okay. All right, so you should have your mean is 21, your sample standard deviation, and let's see, in the directions they said to the nearest hundredth. Okay, nearest hundredth, so 4.08. And then the population standard deviation, 3.87. Okay, good with that? Entering stuff into the calculator? Fabulous. All right, so next page is what? What do we got on the next page? Do we have fitting functions next? Yes? Okay. Fitting functions. Okay. Let's see. Let's do. I'm just looking, trying to pick out a good one here. Let's do number 3. Okay. 2 data sets are being compared. Okay, so they're not giving us any context here. Okay, there's no context. They just said data set A, data set B. Which type of regression model will be the best fit for this data? So I would say, okay, I got to look at a graph here. I got to see what this looks like. So I'm going to take and make, go into my lists and spreadsheets. And I'm going to fill in my 2 lists, call one X and the other one Y. Okay, so once I get them both filled in, I want to see a graph of it. I don't want calculations right now. I want to see a graph of it. So that's where I've got to go to Document, Insert, and I want a Data and Statistics page. Okay, so now it just took that data and literally threw it onto the page. Now we got to organize it. X. Okay, so there's a dot plot, and then I want Y. Okay, so this is my scatter plot. Okay, this is my scatter plot. What type of regression should I pick given this shape, Sean? Yeah, quadratic all day long. Okay, so that's what you want to fill in for the regression model that fits this. Sometimes when you're given context, obviously then you can kind of think in your head, okay, what type of model would be best? But they gave us no context here, so we had to rely on looking at the scatter plot. Now it says, write the equation of your regression model. Now this has to come from the calculator. The calculator has to generate this for us. So when I go back here, I'm going to go to Menu, okay, Analyze, because I want it to write the equation for us. Regression, and we said it is quadratic, so number 4. And there's my equation.
Okay, so they put in 1x squared minus 8x plus 18. You can just write, make sure you write y equals, obviously, because they asked for an equation. Don't just write x squared equals negative 8x plus 18.
Okay, y equals x squared minus 8x plus 18. Be real careful, okay, when you're looking at the calculator. Now they've got a 1 point here, then they inserted that multiplication sign, then they have a plus minus. Be very careful when you're reading it, especially the day of the test. If you look at it quick, you might miss something, you might miss that negative and call it a positive 8x. Just read it very carefully before you put your answer on the paper, okay? All right, let's do, fitting function. Was that it? Was there just 3 questions on that? Or is there more on the back? I have a hard time because my document isn't together. Oh, all right, yeah, we can go on to the next one. So let's go on to linear and other regressions. Let's see which one looks interesting. Which one? Oh yeah, let's do number 3. Okay? This one looks kind of interesting. I mean, it's pretty warm out, but we can think about a cup of hot coffee. Okay? So a cup of hot coffee is poured into a travel mug. The mug is taken out into the wintry weather and begins to cool down over 5 minutes. Using an exponential regression, we're telling you what type of regression to take here. Okay, to model the drop in temperature, predict the temperature of the coffee after 6 minutes to the nearest degree. Okay, so we want to enter, again, 2 lists, our X list and our Y list. I would absolutely look at the scatter plot. They told us exponential regression to give us our equation, and then we're going to use that because that equation is our predictor. Okay, that's our model. So I'm going to pause again so we can enter this info. Turn this back on. So once we have this entered, document, insert, data and statistics. Let's look at it. They told us it's exponential, so let's see. Okay. Okay, it tends to look a little linear there, okay? But I bet if we had more data, we would see, okay, that it is exponential. So let's go to menu, analyze, and they did tell us exponential, so that's the one we must pick. Okay, exponential is way down there at number 8. Okay. And then I would write all of that down the way you see it, because then we're going to use it and then we'll round our final answer. So don't round anything in the equation. Write exactly what your calculator gives you on your paper. Somebody's going to have to I wonder if I can copy and paste this. Probably not. Okay, somebody's going to have to read that to me because I don't have that on my answer sheet. So it's y equals what? 2 8? No parentheses, okay.
0.8811.
With the x, right? Okay. All right. So now, this is our time in minutes. So that was our x, and then our temperature was our y. So it says predict. This is our predictor. Okay. Our equation is our predictor. So it says the temperature of the coffee after 6 minutes. So what am I going to do with the 6? Plug it in for the x. Okay. And then go right to your calculator. Do not round until your final answer is ready. Okay, so that whole thing you're going to type in to your calculator to get your answer.
Don't round until you're ready.
Right.
Exactly, round at the last possible minute. All right, so I'd go to my calculate page. 180.418. 180.418 times point, what's it? 881403. 81403. And that's raised to 6. Now we can round, and they said to the nearest degree, so 84.5916 to the nearest degree is 85. 85, okay? We just looked to the 5 there, and that makes that an 85 nearest degree, nearest whole number. Okay? 85.
Doing okay so far? Okay, and do you see, look at the pattern on here. So the 6 would go there, and then 85, so it continues to decrease there. Oh, you don't get to. This would be so much fun.
As only I would think that it would be fun.
So let's see. Is exponential a good model given this data? How can I determine if exponential is a good model? What do I use?
The residual plot, yeah. So back in our calculator, so I'm going to X out of that. So here, so now I've got to go to menu, analyze, residuals, residual plot. Okay, is the residual plot nice and scattered?
Yeah. So what does that tell us about exponential regression? Was that a good model for that data? Yeah, all day long. Okay, if you see a shape, a general shape to your residual, then you know the model you picked was not good for that data. Okay?
All right, let's see where we're at next. What do we got? Linear regression is just so boring. Predict daily campaign that will meet the goal codes. Let's see what else might be exciting. That's it. You guys good? Okay, because linear regression, you're just going to pick linear off of your calculator. Same deal. Okay, we good? Fabulous. Nice job. Nice job.